When the Scripps Center of Marine Archaeology wanted to kickstart actually excavating underwater, we started our collaboration with the University of Haifa and the Rekanati Center of Maritime Studies under Professor Asaf Yasur Landau. And Asaf suggested that we begin our work together at Tel Dor, in the waters of Tel Dor, which was one of the most important ancient ports in antiquity. So that was that's our long-term research focus. And it's there that we decided we wanted to really expand our understanding of the paleo environment. So that's when we decided to bring Gilad Steinberg into the story. And Gilad, it's been so great working with you. And when we started to get the cores in this area, we worked very close to the shoreline of the South Bay of the ancient port of Dor. There are a number of small bays there. And the South Bay we can see to my left, it's in big letters, South Bay. Could you say something about the strategy we use to core in this area?
Yeah, so in the South Bay of Dor, we used the geoprobe, which is basically the coring rig that we mostly use in the coastal plain of Israel, that I use through my PhD research. And this coring methodology lets us retrieve continuous core records of the stratigraphy of the area. And this is such a good methodology to use, just because using this coring methodology, we can understand the environment and the changes that influenced, leading to its current morphology.
So we got a number of cores indicated there, D4, D12, D6. One of those had a big surprise for us. Which one did this start to reveal? Which core started to reveal the surprise?
Well, we conducted this coring over two coring expedition. In 2018, we retrieved core D4. And in D4, after extracting this core out from the surface, I was very surprised to see this very thin sand unit.
Well, let's look at it. Hang on. Can we have the next slide, please? Let's look at it. Okay. So I remember that day. I came into the lab at Scripps, overlooking the beautiful Pacific Ocean. It can't be a better place to work. And there was Gilad, and then in walked Professor Norris in his white lab coat, and you guys were all excited. Can you point out what that layer was that you, go ahead, show me which one it was again?
So it's the lithological unit called F3. You can actually see it between two black layers.
Got it. F3. Okay. Dick, what got you guys so excited about F3?
Yeah, what we were doing was we were cutting open these cores, these tubes of sediment with a saw, and each one started to show the same kind of thing, this layer of sand in between darker colored sediments that we thought represented wetlands. And then the really cool thing about that was that the sand layer contained shells, marine shells.
Now, wait a minute. We're on land. You're not talking about like land snails. You're talking about like mollusks, right?
Yeah, marine shells and little pieces of clay and stuff like that just didn't look like a normal deposit. And what was so interesting about it was that core after core, when we split them open, we all saw very similar kinds of layers like this, which was not what we expected.
Based on these data, there's no question that we identified an ancient tsunami event in the core record from Dor.
So the key variables are what the water depth is, how big a submarine slide has been generated when the earthquake strikes, how much of the continental slope failed, basically. That creates a displacement, which is what you see in that big wave. And then there's the issue of also how far from the coast the submarine slide happens, because that determines how rapidly the wave will reach the land surface. And you can see in the model that the wave is overwashing the coastline and is presumably decimating any coastal communities that might have been there. I think another cool thing you can see in the simulation is the orange area. So that was the area that got inundated by the tsunami wave. And it's not really uniform along the coastline. So the area immediately opposite the slope failure really gets hit. And then a little bit farther north as well, up closer to the town of Haifa.
So we nailed the age of this tsunami deposit to 7,900 to 7,300 BC. And we did this using a relatively new innovative technique called optically stimulated luminescence dating. OSL dating dates the last time that sand grains were exposed to light. So we were able to subsample the cores in the dark and then bring them to my lab at Utah State University to determine how old they were.
Yeah, so we're thinking that these marine shells were transported over a distance of 16 kilometers.
16 kilometers. That's like, 4 or 5 miles, right? So Israel was bigger in those days.
Yeah, during these times, the sea level was much lower, so the coastal plain was much, much wider.
We are now at the Nahal Oren Neolithic settlement. This is a pre-pottery Neolithic A and the B settlement, very large one, probably the largest in the area of the Carmel. When the tsunami was hitting the coast, it could have had a very, very strong effect on this early Mediterranean economy, impacting the fields, impacting the livestock, causing perhaps an irreparable damage that took much time to recover from. This is an event during a time in which society was beginning to form as sedentary society, and village life was in its very beginning. We can only imagine what consequences this event or this mega event had on the belief system of the people that resided here.